Hey guys, welcome back. Let's try a new challenge. Here we have the question that says, which term of this sequence, 21, negative 7, 7 over 3, is equal to 7 over 243? Ooh. So we're definitely going smaller. We got fractions happening here. Let's see how they all play out. Okay, my favorite thing to do is to always write out our sequence. We have 21. Then we have, make sure I don't forget it, negative 7, and then 7 over 3. Okay, I'm pretty sure we can see instantly that we're not going to be doing an arithmetic. And let's see, for example, to go from 21 to negative 7, we're going to subtract 28, right? And to go from negative 7 to 7 over 3, we're definitely not going to be subtracting 28 again. All right, so we can clearly see that this is not arithmetic. Then let's jump into our geometric testing, right, to find out what the common ratio will be. So let's label our terms. We have term 1, term 2, and term 3. I'm going to start off with term 2. And then whenever we are doing, like say for example, I say term 2, we have to do the term 1 less than that, okay? That will be divided by, so it'll be divided by term 1. If I'd started at term 3, it would need to be divided by term 2. And if I'd started at term 8, it would have had to been divided by term 7, and so on and so forth, okay? That is pretty much the way the structure goes. And remember, you can start at any number, as long as the term you're dividing by is 1 less than the term at the top, okay? The numerator. Fantastic. So let's look at our first challenge, which is term 2 divided by term 1. Term 2 is negative 7. Term 1 is 21. Okay, so a negative is going to stay, and 7 goes into 21 3 times. So we have negative 1/3. Let's double check it on the second round. So we have 7 over 3 divided by negative 7, which I like to look at going 7 over 3 divided by negative 7, which is the same as saying 7 over 3 multiplied by 1 over 7. Am I going bonkers? No, I'm not. Bam, bam. Oh, remember the negative. I nearly forgot it, okay? Those 7s cancel each other out, leaving us with negative 1/3. Wow, that was a very long way to get to an answer. You could have simply just plugged the first one into the calculator, but it's always good to exercise that math muscle of yours, okay? Awesome. So now we agree that the ratio is negative 3. I'm just going to write our general we're not even ready for general nth term. Let's talk about writing our standard formula for us first. Okay, so we have Tn is equal to a times r to the power of n minus 1. Okay, so we have spoken about in the past, a is always the value of the first term, so a is equal to 21, and r is the value of the ratio, the common ratio that we see happening through the actual sequence. That's what creates the different numbers. All right, cool. So our ratio here, and we proved it to be negative 1/3. Ooh, we're going to be working with a fraction. Always interesting. Okay. So let's plug in the information we have and find out what our general nth term is, right? Okay, so Tn is equal to 21. Yeah, 21, because remember a is equal to 21. 21 multiplied by a ratio, which is negative 1/3. Okay, and that will be to the power of n minus 1. Okay, so this is what we have so far. What I'm going to do is just scoot all of this stuff out the side, so that I can make a little bit more space for us to do the actual calculations. Now if I can move everything politely, that would be great. There we go. Nicely done. Alright, so now we have assumed that 21 times by negative 1/3 to the power of n minus 1 is our general nth term. The reason why I say we assume is because we actually haven't tested it. Let's do that, alright, before we go anyway. Now let's look at this. I'm going to choose the second term, just because, wow, the third term is a fraction. Although we could do either one, but I'm going to go with the second term. All right. Because I'm doing that, I'm going to plug a 2 into wherever I see an n. So let's do this. We've got T2 is equal to 21. Oh, my pen is being delayed. 21 multiplied by a negative 1/3, and then I bump into another n, so I've got to plug in a 2, all right, and then minus 1. Cool. At this stage, you can obviously plug it into our calculator and just get a straight answer, okay? And you might find that you like to do that just to get the maths done with. Some people just don't take maths. It's okay. We all have our favorites and our not so much favorites. All right, so what we're going to do now is I like to go each step because I like to exercise the math muscle. And I'm going to start off by simplifying our exponents. Here we go. So 21 is going to stay as is. My negative 1/3 is going to stay as is. And then I've got 2 minus 1, and that's going to turn into 1. All right. If you have an exponent with a value of 1, there's no real need to write it in. I'm just going to put it in there for now, because every single number that you don't see that has an exponent actually has an invisible 1. Okay, that is what it actually stands at. So if we had to now see 21 multiplied by negative 1/3, let's write that out a bit so we can see what's happening. Okay, I have 21 over 1 technically multiplied by negative 1/3. Now the reason I've done this is because I can see that 21 and 3 can be simplified, and so I'm going to do that while I have a chance. 3 goes into 21 7 times. So our answer here is going to be negative 7. And what is the value for T2? Aha, they said negative 7. That means our general nth term is correct. Wonderful. All right. Now we're going to start getting our hands really dirty, because this time they have not asked us what number or what value a certain term is. They've given us a value, and now they're going to have asked us what term it is. All right. So we're still going to use the general nth term. All right. Starting off by putting it on the right hand side of the equal sign. Okay. So we got 21 multiplied by negative 3 to the power of n minus 1. Now, usually on the left side we would say t and the number term we're looking for. We don't have that as a challenge. We have a value. So we simply put in our value, which is 7 over 243. Wowee. Okay. So now what we're going to do is we're going to start breaking up our equation, messing and manipulating with it until we have our variable by itself. Okay. Now please note our variable is in exponent form, so we know there's going to be quite a bit of poking and prodding and squishing and squashing. Okay. So, but we'll have everything sorted out soon enough. The easiest thing to start off with is to separate the 21 and the negative 1/3, and they're being multiplied. So in order to separate them, we just simply do the opposite. Okay, so I'm going to divide this by 21, and to keep balance I'm going to divide this side by 21. Okay, so the 21s cancel out. This actually ends up being 7 over 243 multiplied by 1 over 21. Okay, please feel free to plug that into your calculator. It is a huge mouthful, and I'm not going to go through all the steps. Let's just put in the answer, shall we? Okay, and that comes to 1 over 729. Bam. Okay, is equal to negative 1/3 to the power of n minus 1. Okay, and as we did, I think we should keep these in brackets because that negative is definitely a part of that challenge. Okay, so now we have that a little bit summed down. I want to quickly get rid of that n. That looks very untidy again. Crazy lady and her neatness. Okay, n minus 1, that looks much better. Okay, now as we did in the previous window or video, I'm not too sure if you watched it, but the game plan now is to get our base numbers the same. Okay, so the base number will be negative 1/3. All right, and I want my 1 over 729 to also have a base number of a negative 1/3, because then and that'll be like a negative 1/3 to the power of something, so that we can get rid of our bases and start working with exponents. Okay, so let's check what's going on here. Ooh, sorry, itchy nose. Okay, we have 1 over 729. Sorry, my pen seems to be weird today. I don't know what's going on. Okay, we're going to divide that by negative 1/3. And that's going to give us 1 over 243. A negative 1 over 243. I mustn't forget that negative. We're then going to divide it by negative 1/3 again. And this time it's going to turn it into a positive. And we have it as 1 over 81. Pretty cool. I'm going to divide it again by negative 1 over 3. Okay, so we know our answer is going to be a negative something, and it's going to be negative 1 over 27. Okay, now taking this one also, I'm going to divide it by negative 1/3, and that is going to give us just 1 over 9, because a negative times a negative gives us a positive. Let's go ahead and divide that by negative 1/3, and that's going to give us negative 1/3. Oh, this is looking so good. We're going to divide that by negative 1/3, which is going to give us an answer of 1. Very cool. Now we know we got it right because we got a 1, all right? That's sort of like a key card. Now let's go ahead and count how many we got. 1, 2, 3, 4, 5, 6. Okay. So now on the left-hand side of the equation, we can open up brackets, say negative 1/3 to the power of 6 is equal to negative 1/3 to the power of n minus 1. Okay, so because our bases are the same, remember these guys here are our bases, okay, because they're the same, they can drop away, and we will just be left with the equation. I'm going to plug in a different color. It's going to be 6 is equal to n minus 1. All right, now we're doing, like, that looks like so easy compared to what we were working with earlier, and it is easy, okay? We're going to take that negative 1, we're going to chuck it over to where the 6 is, so we have all the constants. And remember, when a negative goes over the equal sign, it becomes a positive, so we have 6 plus 1 is equal to n, and that means 7 is equal to n. And we can finish it off by saying, therefore, T7 is equal to 7 over 243. Okay, pretty easy going actually when you take it slowly and you work through the process. Thanks for joining me, guys. I hope to see you on the next video. Cheers, bye.